I think I'm live. So hi everyone, and yeah, there are a couple of you have joined. So let me know how did the contest go. And yes, I'm back at my home, so I do have my setup today with me. So I think we should be good today. So yeah, let me know how did the contest go for you? How were the problems? Did you like the problems? Did you not like them? I see the accuracy percentages are pretty low. Like I expected them to be high, but again, like that's totally fine. So yeah, let me know how were the problems and if you faced any challenges and anything. And after that, we'll go through both the problems one by one and we'll learn how to solve them. Okay, I do have my code written and I'll just rub that off for now. Yeah, let me know how did the contest go for you. Also, before that, can you also let me know if you guys can hear me? So I'll just okay. I think I can hear myself, so we should be good about that. So yeah, how did the contest go? Any problem that you were not able to solve? There were two problems, and I think both were pretty easy. So was there any problem that you weren't able to solve, or how would you rate the contest? Did you like the contest overall? And let me know what these things. So if you can write in the chat, it will be really great. So yep, let me know. Cake has written, yes sir. I'll just rub both the codes. Okay, anyways, without wasting much time, let's get started with the analysis of the problems. Uh, Add a problem in the test case starting to have greatest number. Okay. Okay, we'll see how we can do both the problems. So let's start with the first problem, that is maximum distance between geek and his friend's car. So the problem statement is pretty simple actually. So what it tells is geek and his friend are playing a card game. Other question didn't show Java option, and in this question it was easy but couldn't find all options correct. Okay, we'll see. So Geek and his friend are playing a car racing game. Given an input array A of size n, Geek and his friend can start at any index in A and can move their car either one index on the left or one index on the right if it exists. Also, Geek and his friend can't move their car to any index such that the value of A on that index is smaller than the current value at the current index. Your task is to find the maximum possible distance between Geek and his friend's car. So note that Geek and his friend's car will start at the same index given the array is zero based indexed, right? So what it basically tells us is that we have an array given to us, right? We have an array given to us. There are some values. Let's say both of them start at index I, right? So both of them has to start from a given index. He can move one direction and his friend can move in the other direction, right? Because we have to maximize the distance between them. So it's always better for us to move them in opposite directions if it is possible. Otherwise one of them will stay in this place and the other one will move in one of the directions, right? So it's always better for us that one of them moves on the left, one of them moves on the right, because that will always maximize our distance. If that is not possible, if one of them is not possible, we'll always try to move the other one and keep one of them fixed, right? So that will be the best possible, that will be the worst possible scenario that we can have. So it tells that let's say friend moves in this direction, like it doesn't matter, geek moves in the left or right or friend moves in left or right. We can just use one of the directions for one of them and the other direction for the other of them. So friend moves in this direction, geek moves in this direction, right? So both of them are moving in opposite direction. They're starting from an index. Now a condition is given to us. They can only move to the next cell if a of new cell, right, a of new cell is greater than equal to a of current cell. that is the value is greater than or equal to the current cell value, right? So only if the value of the next cell that we are moving is greater than or equal to the current cell value, only then we can make the move, right? So what does this tell us about what does this tell us, right? What does this statement tells us? This statement clubbed with this statement that they start from a given index, both of them tell us that this is how they will be moving, right? Like the array should be like this around an index I. So this is an index I. The array should be like this around an index I. There might be some elements common. So the condition was a of next is greater than equal to, right? So there might be some common elements as well in between, but the array should be something like this. The array should be something like this around some index I, and in this case the friend can come here, let's call it F, and geek can come here, let's call it G, the last element, and the here also the last element, and this is the maximum possible distance they can go up to, right? So both can move in two different directions. One will move to the left, one will move to the right, and the array has to be around index I. The array has to be something similar to this. There might be some common places, like there might be some common elements here, like let's say like this. They can have some common elements like this and something like this, right? But anyways, the path will kind of look like this. So this is the question, right? This is the question. We have to find that index I, or rather we have to find the maximum distance between friend and geek. Like what is the index I against which we can move farthest to the left and for the farthest to the right? That is it is increasing on the left and also it is increasing on the right. What is that point index I, right? So we have to find that, right? That is the question that is given to us. How do we do this? Okay, to do this, can anyone would anyone like to give a try? Like how would we do this? Also, one more thing, we haven't looked into the what is expected from us. So we want a order of one complexity and the order of n time complexity, right? Order of one space complexity, order of n time complexity. So we have to do this, right? Okay, so I think it's pretty simple if you are using a order of n space complexity, right? Because you can always pre-compute for every index I what is the maximum on the left you can move, for every index I what is the maximum on the right side you can move. If you have pre-computed this, your answer will be max right of I minus max left of I plus minus max left of I, right? This will be your answer. For every index I, you will compute this and you will find the maximum on all possible values of I equals to 0 to n minus 1, right? So you can just quickly compute this and it will take a order of n space complexity as well, right? It will take a order of n space complexity, but we have to reduce this to order of one space complexity. We cannot use an additional array, right? So one observation here is that, let's say we have around an index I, we have something like this. Around an index I, we have something like this, right? This will always be the best possible case in this entire range that we have. Like wherever we have this maximum, right? Wherever we have this maximum, it will always be the best possible case. If you look around this, you will always see that if you go to I plus 1, right? If you are going to I plus 1, you wouldn't have like this. You would only have something like this, because this one is less than I is less than I plus 1, right? So you cannot go. No, it is not a graph question actually. It's a simple greedy type question. So just like few observation based. So at I plus 1, you can just go in one direction. So it is always better to start from I. That brings us to the conclusion that, and even if you go to I minus 1 as well, you will see that you cannot have something like this at I minus 1, because I is less than I minus 1. So, and you are telling here that I is greater than I minus 1. So both of them cannot be true at the same time, right? So at I minus 1, it will be a straight line like this. That is, only one of them will move, the other one will remain at I minus 1. With this, we come to the conclusion. We can actually come to the conclusion here that we can break these kind of structures, right? This is kind of a like it's decreasing and then increasing absolute function, similar to an absolute function. So we can have these kind of structures, but they all will be disjoint. There will be multiple structures like this, but they all will be, yes, that's what I'm coming to. All of them will be disjoint, right? All of them will be disjoint. So basically what I mean here is that we can have multiple structures like this in the array, but they all will be disjoint. That is, they will not start, no other such structure. This structure will not start anywhere in this range in which we have this structure, right? So it will be disjoint, that is if it ends at index 5, this should start at least at index 6, or at least at index 6 or more than index 6, right? Similarly, let's say this ends at 10, this should start after 11, right? At 11 or after 11. So that means all of them will be disjoint, right? All of them will be disjoint. So what we can do is, we can, for every index, we will try to move to the left as much as possible and to the right as much as possible, right? We'll try to move to the left as well as right as much as possible. Once we reach the optimal points, we know that we cannot have any suboptimal region in between. We'll always go to the next possible, like next set of points, right? Next set of indices. So we can use a 2-pointer like approach here. So what we'll do is, let's take an example. So 1 2 3 4 5, maybe 1 2 3 4 5 I believe is simple. So 4 3 3 is okay, or maybe we can take a bit complicated example. So let's take a complicated example about what we'll do here. So what we can do here is that, let's take an array here, A. Let's say 1 2 1 3 4 1 5 2 6, right? Something like this, right? So we start off our pointer, we'll start off 2 pointers from here, pointer 1 and pointer 2. Now we'll see, first our pointer 2 will always move to the right, our pointer 1 will always try to move to the left, right? So pointer 2 will see if we can move to the right, that is if this element 2 is greater than equal to 1, yes it is, so we can move to the right. Yes, intuition is simple, but I understand like it might take some time. So we will move to the we'll move to the right, right? So because we can make a move because 2 is greater than 1. Similarly, after this, can we make a move to the right? No, actually, because 1 is not greater than 2. So we cannot move to the right. Can we move to the left? We cannot move to the left because we are at the leftmost point. Our left pointer is at the leftmost point. So we cannot make a move here. So we update our answer. Our answer here becomes 1. The distance between them becomes 1, and we'll start directly from the next set of points, that is our pointer 2 will come here, that is to index 2, and our pointer 1 will also come to index 2, this point, right? Now from here, what do we do? First of all, we try to move the right pointer. Can we move to the right? Yes, 3 is there, 3 is greater than 1, so we can move to the right. So we'll move to the right, okay. Can we move to the right again? Yes, we can move to the right because 4 is greater than 3, so we'll move to the right again. We move to the right. Now it's time for us, we cannot move to the right anymore. Now we'll try to move to the left. Can we move to the left? Yes, we can move to the left because 2 is greater than 1. 2 is greater than 1, right? So we'll move the left pointer to the left. 2 is greater than 1. Can we move to the left more? No, we cannot, because 1 is less than 2, right? 1 is less than 2. So this is the distance that we get now. And we cannot get a better distance in this set of indices, that is 0 1 2 3 4. In this set of indices 1 2 3 4, we cannot get a better point, right? So the answer here will be, what is the distance? 3. So the answer is updated to 3 now because 3 is better. So answer will be updated to 3. Now we do not recompute again because we know that for these set of indices we have found the best possible answer. So we'll directly move to the next point, that is our left pointer will move to this one, and our right pointer will also move to this one. Okay, now we again see, can we move our right pointer? We can move our right pointer. 5 is greater than 1, so we'll move it. 5 is greater than 1. Can we move our right pointer? No, we cannot move because 2 is not greater than 5. So can we move our left pointer? Yes, 4 is greater than 1, so we can move our left pointer. Okay, what do we get out of here? We cannot move our left pointer anymore because 3 is here. So what is the answer that we get out of this? We get, the answer is 2, right? 2 is not better than 3, so we will not update it. Now we know that from these set of indices, we can get the maximum answer to be 3. We cannot get anything better, so we'll directly skip to the next possible set. So we'll come to this 2 and 2. Now can we move the right pointer? Yes, we can move. So once we reach the right, our right pointer reaches the end. Can we move our left pointer? Yes, we can move our left pointer. Because 5 is greater than 2, so we'll move it, and that is the best we can do, right? So again the answer is 2 and we don't update, so we move to the next possible point, that is we go out of the array indices and we have our answer to be 3 here. So 3 is the maximum distance between them. So this is how we can quickly solve this. So let's look into the code and let me know if you have any doubts. If you have any doubts with how to solve this, let me know. Meanwhile, we can start writing the code for this. Sorry, I opened OBS. So what we can do, int ptr, let's call it left, right? Ptr left equals to 0, pointer right equals to 0. Right, pointer left equals to 0, pointer right is equals to 0. Now answer equals to 0 initially, while pointer right is less than n. While we are within the array bounds, while pointer right is less than n, let me just go to full screen mode. So while pointer right is less than n, we'll check if we can move our pointer right to the right. So if pointer right, if a of, so if pointer right is less than n minus 1, and also a of pointer right plus 1, a of pointer right plus 1 is greater than equal to a of pointer right. So a of pointer, that is we can make a move, right? So if we can make a move, so we can go to pointer right plus equals to 1, right? Else if we can move our left pointer now, can we move our left pointer? So we can check pointer left is greater than 0 and a of pointer left minus 1 greater than equal to a of pointer left. So pointer left minus equals to 1. Else what we can do, is if both of them are not true, we cannot do anything. So we can directly go to pointer right plus equals to 1 and pointer left equals to pointer right. That is, we move to the next index, right? Pointer left equals to pointer right. So answer will always keep on updating our answer. Answer equals to max answer and pointer right minus pointer left. Pointer right minus pointer left. So this is the code, and now we can just quickly return answer. Return answer, and that should be the code. Let's try to compile and run this. Anyone has any doubts with the logic? I think it's pretty simple. So output is 4. I think it's working. So let's submit and see if it is working. Okay, so it's done, right? It's done. We have solved the problem. So yeah, let me know if you have any doubts with this. Anyone has any doubts with this, how we are doing this? And why is the complexity, the space complexity is order of 1, right? Because we are just using 2 pointers. Why is the time complexity order of n? That is because in a given set of indices, like if you see, we are actually moving across disjoint set of such like low highs, right? So even actually we are going visiting every value only once or twice, right? So that's why it is order of n. So if you think about it like this, that we have a disjoint set of like these ranges, right? So that's why it's order of n, right? Like this. So this is kind of like the graph, how it looks. So they are kind of disjoint, right? So that's why it works in order of n time. I was able to solve one question. May I get selected for interview? I'm not sure, like this is not an interview selection, this is just for a practice, but yeah, like in your interview selection round, if you are solving one question, it depends on how many others are able to solve. So let's say there are like around 100 people shortlisted and all the 100 people solve 2 problems, then you will not get selected. So you have to solve 2 problems to get selected in that case. But if the problem are difficult and you are able to solve one of them and most of them actually solve one of them, then yes, there's a chance that you will get selected. For the case when the array is on the left, for the case when the array is non-increasing, okay, array is non-increasing, 1 second. array is not increasing means array is decreasing, right? So you're telling 5 4 3 2 1. Okay, we'll start up our right pointer and left pointer here. Here it cannot move, so we'll move to the next place. Right pointer comes here and left pointer comes here. So left pointer actually sees that 5 is better, so it will actually go to 5. Yes, it might actually go up to n square in non-decreasing. So can we optimize on the left pointer? I think it should be a simple optimization on the left pointer. So can we block it somehow, or can we memorize what is the best, or can we just maintain what is the maximum to the left it has already moved, right? Before we are jumping forward. So let me think about this. Is it actually in square? Yeah, let's see. 5 4 from 4 it will again move to this much, and it will see that it cannot move anymore. So we'll come here. Now the second pointer also comes here, and it sees that again it can move, so it's actually moving through all the values again and again, right? So it's actually becoming a n squared. Yes, that's true. So what we can do here is we can we memorize somehow, like what is the maximum it has moved, or what is the maximum on the left that it's decreasing? Can we actually recall this? Let's see. So if it is non-decreasing, right, if it is non-decreasing, so can we do something here? If pointer left is greater than 0 and pointer left plus 1, pointer left minus equals to 1, yes, maybe we can have to add some conditions here more. Let's see. So we don't want to move pointer left, right? Yes, time complexity, yes, it was not linear actually. I think the test cases were weak. But can we actually restrict our pointer left? Can we restrict our pointer left movement? A of pointer left minus 1 greater than equal to a of pointer left. So what we essentially want is how much can we move to the left, right? How much we can move to the left. That's what we want. So if we are moving to the right, let's say we have moved to the right for some places, we can maintain something like this, that what was the current point across which we are moving. So current point equals to 0, right? Current point equals to 0, and here in this case, else case, our current point becomes current point equals to ptr, right? That is against what we are moving, like that's the starting point, or that's the diversion point, or the starting point. Let's call it starting point, st point, starting point, st point, and our starting point is this, right? So we can add a conditional check here. That what is the conditional check? Like if it is so if it is left pointer, how much we can move? So our left pointer, we can, as it is increasing, right? If it is increasing at any point, right, so we cannot move our left pointer. If it is increasing at any point, we cannot move our left pointer. So here we can actually check, here we can actually run a check that, hey, if the current point, the right point, right, if the one second, if the right point, if the ptr right, sorry, ptr right, or the if the ptr right is equals to the right point, right? If it is equal, that means it's a decreasing one. It's a decreasing one. That's why it's not able to move forward. So we can memorize actually, right? So one second. PTR right, a of PTR plus 1 greater than equal to. Can we memorize from here how much we have moved, how much our left pointer has moved? We can just add to that. So left pointer we can actually just do, or we can actually not move our left pointer that much, right? We can actually just keep our left pointer to such a place where it's just increasing. So can we somehow maintain that? Check the max value of left pointer movement. Pointer left movement, what is the max value? Why do we want that? Let me think. Let's think about this a bit. So let's see. we don't want we don't want to actually come back here again, right? So when we are moving to this point, we should know how much our left pointer has traveled, right? Because here it is decreasing, so we can somehow, we have to maintain, when we move here, we somehow have to maintain what is the maximum left pointer has moved here, right? That is because that then we know that it was decreasing in this phase, and we can easily know about that because our current in our new pointer will be equals to the current like the previous pivot plus one, right? Because our right pointer hasn't moved then actually. So in that case, what we can do is, if our right pointer hasn't moved actually, we can actually just maintain the value, like how much has it gone, right? So let's see how we can maintain that. So we can maintain it in a variable. So this will be previous starting point, right? So this will be previous starting point equals to 0 int left move, right? Left move is equals to 0. So pointer right is less than n minus 1. That's fine. If it is actually increasing, then it's not a problem anymore, because then it cannot come back, right? The left pointer will cannot come back. But if it is decreasing, in that case we have to greater than equal to this. So we can do left move plus plus, right? Left move plus plus equals to 1, and ptr left equals to ptr left equals to ptr left minus minus, right? Ptr left minus minus. Now else ptr right equals to plus equals to 1, ptr left equals to this. Now ptr left will not move it to ptr right actually. So we'll check here if the starting point, right, if the previous starting point, or rather yes, if the previous starting point. So here we can make the previous starting point as well. Previous starting point equals to ptr. Previous starting point will be what? Previous starting point will be equals to for the next iteration. Okay, for the next iteration, we'll have our previous starting point will be ptr right plus 1, right? So ptr right plus 1. So if previous starting point is equals to ptr right minus 1, means the right pointer hasn't moved actually, right? The right pointer hasn't moved at all. Or we can set a boolean value as well and set this to true. In that case, will is not equals to, right? If it is not equals to, then only we'll set our ptr left. So in that case, we'll set our ptr left equals to ptr right. Otherwise, we'll keep our ptr left in the same point. Ptr left equals to ptr right. Otherwise, we'll set our ptr left in the same point. And I don't think we need this left move anymore, because it's already in the same point. And it's decreasing anyway, so we don't actually care about that. So left move is not needed. I think that should actually do this. Let's see if this actually solves the issue. I think it does. So it is mandated that left ptr will be recalculated for each of distant and left pointer. Okay, it's not 433. Answer is 2. We are getting 3. Why are we getting 3? 433, right? So 4 means, what I'm trying to do here basically is that whatever the left pointer has moved, if my array has been decreasing, like if I have a decreasing value here, that means my left pointer would anyways move that much, right? So let's say the left pointer has only moved, and this is a decreasing part, right? So this is an increasing part. So it's something like 432, right? 432. So my left pointer will anyways move this much. Now when we come to this 6, and the right pointer hasn't moved, right? So definitely this should be less, so it should be 1. So my left pointer would anyways move up to 4 only, right? It will anyways move up to 4. So I just want to maintain the left pointer here itself. I don't want to carry it forward. But in case of 433, let's see actually 433 what happens. So let's actually erase this 433. Let's run this through once. 433. Himan, just give me a second. I'll read your comment, but let's once quickly run this through. So 433, pointer right is moving. So pointer right cannot move. So our pointer left also cannot move. So the answer is 1. Now we move here right, but left pointer should remain here, right? Left pointer should remain here, and it cannot move anymore. This also cannot move. So it will. Okay, I haven't added a condition here. Okay, I have added pointer left is greater than 0. PTR left minus minus. Pointer right plus equals to 1. Pointer right plus equals to 1. Or we can do something like this. Has bull has made right move equals to false. Equals to false, yes. And whenever it makes a right move, we can set this to true. So has made right move equals to true, and here we can check if has made right move. If not has made right move, or rather if has made right move, in that case pointer left equals to pointer right. Otherwise we will not say. So we don't need previous starting pointer anymore, right? So that should be here. Compile and run, and 433 will test again once. So 433, right? So 433, it should give us 2. Let's see how much it gives us. It's giving us 2, so I think that should be it. So let's see. Why are we getting 2 here? Like, it's impossible to have 2, right? Is pointer, it goes here, pointer 2 comes here. If pointer right less than n, okay, pointer left minus minus, pointer left equals to pointer right, and pointer right plus equals to 1. So 1 second, how does it become 2 anyways? Like, we are anyways making answer equals to okay, 1 second, pointer right minus pointer left, yes. So we should make the answer once we reach here, right? Once we reach here, we should update our answer, pointer right minus pointer left. So I think that should actually help us. That is only when also it will not actually help us, like pointer right, it helps us actually, yes. Okay, so I think you got the logic right. Now it's order of n. If you see, now it's order of n, because we are remembering, like, if it is decreasing, right? If it is decreasing, only in case of decreasing, right? If it is increasing, like if we have a 4, after that we have a 5, in that case, let's say after that we have a 2, right? So in that case, when we move to 2, we cannot move more than one place. We cannot move our left pointer more than one place, right? It will move to 5, and after that it will anyways be less, right? So if we can make a right move, that is, it is increasing here in one step, that means when we go to the next element, we cannot move our pointer by more than one place, right? We cannot move our left pointer by more than one place. And in case of decreasing, we are actually remembering where it was last, so it becomes order of n. We do not update our left pointer, so that's why it becomes order of n. Is it clear with everyone how it becomes order of n now? This will work in order of n. Can SD1 in questions be on design? Might be. But depends. Like, if you are college graduate, might not be, but in some cases, yes, it might be. Is it clear with everyone how is this solved and how is this order of n? Let me know once. Is it clear with everyone? Now it is order of n, right? We just remember, we just don't move our left pointer in case the array has been decreasing. And if the array is not decreasing, like if the right pointer has moved, in that case the left pointer cannot be moved by more than one place, right? That makes sense because the next element has to be greater than equal to. Can you go over again? Yes, sure. Sure, I can go over again. So what basically was the issue? The issue was if the array is decreasing, right? If the array is decreasing. So let's take the case of 433. 433. In the case of 433, the issue is that, or if it is decreasing, let's say, let's take a bigger array, maybe 5432. 5432, right? 5432. The array is decreasing, right? The array is decreasing. So what I've done is, what was the problem? What the problem was that we have the left pointer, we have the right pointer. We see that we cannot move the right pointer and the left pointer, so we go to the next place. Here we move the left pointer by one place, so it comes here. Again, when we move our left pointer and the right pointer, so our right pointer goes by one step forward. Our left pointer comes here. What we were doing, we were resetting the left pointer to this point, and again we're moving back, right? We were again moving back. What I'm saying now, instead of doing this, right, we were again moving back. So every time we go forward, we are moving back this entire place. So it was becoming n square, right? But we see that, okay, let's take a case when the array was like a right pointer has moved, right? The right pointer has moved. That is, the right pointer has moved means, let's say there is some 4. After that, there is some 5 in this case, and there is some 6, right? In this case, the right pointer has moved. Let's say here is 1. The right pointer stops here. In this case, when we reset the right pointer to this, we can safely set the left pointer again to this value. Why? Because the left pointer cannot travel by more than one place. After 6, there is 5, right? After 6, there is 5, so it is decreasing, it is not increasing. So it cannot travel more than one place. So in this case, also we can take care of equal values again. Like if there is equal value like 6, 6, 6, like that, those things we can definitely take care of. But again, it cannot move more than one place here, right? If it is increasing like this. So that's why it is safe for us to actually move our left pointer to this point. However, when we have a decreasing array like this, right? When we have a decreasing array like this, what do? Is we can easily identify if it was decreasing, right? If it is decreasing, that is from 4, let's say it is decreasing, we know that the next, our right pointer hasn't moved. In that case only it is decreasing. That means what? Our left pointer, we don't actually have to reset it to this value, because we can anyways move our left pointer back to this point wherever we are at. So we keep our left pointer wherever it is, we keep it in that place itself. We just move our right pointer, because our left pointer will anyways come back to this point, right? So we just move our right pointer to this point and our left pointer stays here. So that's why we are preventing the recomputation. Like we are preventing coming back again to this point. We are just, we know, because as this is greater than equal to, in fact, for greater than equal to we can do this. Not only greater than, for greater than, like if it is 4 as well, we can do the same thing, right? We know that our left pointer can come back again to this point, so we just keep our left pointer in the same place. Only the right pointer we move forward. So that's why we don't again come back from here, we don't come back here and here, right? We just keep it at the same place. Is this clear? So I think we have missed a condition here. Has made right move. It might be true also. We can make a check here that if it is equals to the value. One more check you can do it here, because if there is equality in value, it will actually make a right move in that case as well. But we should maintain that. So you can just also make a check that, hey, is the value equal, right? You can just store the value here wherever you are resetting, and you can just check the value here that if the value is equal, right? In that case also it can move back. So that's how we can do this, right? That's how we can do this. We are just basically memorizing, like we are just not moving our left pointer when we know that the left pointer can again come back to the same place. And in other cases, we always know that the left pointer doesn't move more than one place, right? We always know. Let's come back to the second question quickly. Let me know if there is any doubts while we discuss the second problem. Do let me know in the chat if there is any doubt. Okay. So the second problem will be maximum subset sum. So this is a pretty simple. This is a to be honest, this is a straightforward question. I think most of you were able to solve this, so you don't have to read in. Okay, this is not necessary. Okay, given an array of size n, find the maximum subset sum of elements that you can make from the given array, given that for every two consecutive elements in the array, at least one of the elements must be present in the subset. So you have to make the maximum subset sum with the condition that maximum subset sum means you have to choose a subset which has maximum sum with the condition that for every two consecutive elements, one of them must be present in a subset, right? One of them must be present in a subset. So for example, 1 minus 1, 3, 4. We can keep 4, we can keep 3, we can keep 1, right? That will, in that way we'll get 8, and we can definitely skip minus 1 because for two consecutive elements, what are the two consecutive elements? Minus 1, 3 and 1 minus 1. In both the cases, we have one of them present, right? We have one present and we have 3 present. So that's why we can definitely skip minus 1. So similarly, 0 to 0, we can definitely choose 0 and 2 or 2 and 0, any one of them, or only 2 as well. So for any two consecutive elements, we always have the same thing, right? So that is the question, right? This is the question. You are given an array size n. You have to choose the maximum subset sum, provided for any two consecutive elements, one of them must be present in your subset, right? So that is the question. So how can we solve this? And let's look into the whatever has been given to us. So n is this range and this, and expected time is order of n, expected space is order of n. So what we can do is, it's actually pretty simple. Whenever you have maximum subset sum or these things, it's obvious that we have to go for a DP like solution. For maximum subset sum, I believe the DP is pretty simple. You can either take an element or you will not take an element or something like that. Although for only maximum subset sum, you don't need in fact a DP solution. You can just go for you can just choose the positive elements out and that will do. But here we have a constraint that we have to choose like one of them. So we can go for a DP like solution, right? We can go for a DP like solution. Although I think there might be a greedy solution as well. But yeah, let's be safe and go for a DP like solution. So n plus 1 and 2. That means that what is DP n plus 1, 2? It means that DP I comma 0 means what is the maximum subset sum we can choose up from the first I elements, provided we have not taken the I plus 1th element. That is, we have to take the ith element. Otherwise, I plus 1, this consecutive set of elements, that will cause a problem. DP I1 means what is the maximum subset sum we can choose from the first I elements, provided we have taken the I plus 1th element. So for the ith element, we have a choice whether to take it or to not take it, right? So DP n plus 1, 2. So let's fill it with some small value. So it will not be int, it will be long DP this. So for int I equals to 0, I less than equal to n, I plus plus, DP I0 equals to DP I1. We'll just set it to some very less value. So minus 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. L. I've just set this to minus 10 to the power 15, right? So just a small value. So DP00 equals to DP01 equals to 0. This is the starting base case. For int I equals to 1, I less than equal to n, I plus plus. DP I0, what does this mean? DP I0, what is the meaning of DP I0? Let's write it down here. DP I0, right? What is the meaning of DP I0? Max subset sum we can get from first I elements, provided we didn't take I plus 1th element. I plus 1th element we didn't take. What does this mean? If we haven't taken I plus 1th element, if we haven't taken I plus 1th element, we have to take the ith element because I and I plus 1th element are two consecutive elements, and for any two consecutive elements we have to choose one of them. So we have to take, this means we have to take ith element. So dp I0 equals to dp I minus 1 1, dp I minus 1 1, because we are taking the ith element. So when we go to I minus 1, we have taken the ith element, so it should be 1, right, plus a of I minus 1. Otherwise dp I1, this means that what, dp I1 is the same thing, but we have taken the ith element. Same thing, but we have taken the I plus 1th element. That means, this means we can decide whether or not to take ith element. We can decide on this fact whether to take or to not take the ith element. So dp I1 will be equals to dp I minus 1 max of dp I minus 1 0 if we don't take the ith element, or dp I minus 1 1 plus a of I minus 1 if we take the ith element, right? So finally we can return what, max of either we take the nth element or we don't take it, n0 or dp n1, whichever is the maximum, that is the answer, right? So we can try running this. Is this clear with everyone? Is the dp logic clear with everyone? I think it's pretty simple. It's just a modification of many other problems like coin change and those things, right? That's given to you. So we are getting 8, so let's submit. Yeah, so it's accepted. So any doubt with this? Anyone has any doubt with this? In fact, we can also solve this in order of one space, like order of n spaces given to us, so we are using this array, but we can definitely solve it in order of one space as well. We just have to remember at every iteration, we just have to remember dp I minus 1 1 and dp I minus 1 0, right? Only these two values we have to remember, right? So we can just maintain two variables for them, and we can completely get rid of this dp array, right? So we can even do it in order of one space. So is this clear with everyone? Why is this working, or how is this working? Is this clear with everyone with the dp solution? How is the dp solution working? Let me know in the chat yes or no if it is clear, if it is not clear. Let me know in the chat. If it is clear, let me know yes, it is clear. If it is not clear, write down no. Can you explain one more time? Sure. Let's use the whiteboard. Okay. I hope you know about coin change and those things, right? How we get those things. So let's understand this. So we are given a set of elements, right? A1, A2, like that. AN. Now we have said that for any two consecutive elements, what is the maximum subset sum that we want to have? Provided for any two consecutive elements. What do I mean by consecutive elements? A1, A2, A3, let's say. So A1, A2 is a consecutive element, A2, A3 is consecutive element, right? So provided for any two consecutive elements, we want to have, what we want to have is, we want to have one of them present. So either A1, A3 is a valid subset, A1, A3, because for any two consecutive element, one of them is present, or A2 alone is a valid subset, right? A1, A3 or A1 only alone or A3 alone is not a valid subset, because A2, A3 will be missing in that case, right? So we are given n elements, we have to choose the maximum subset, some subset, provided we, for any two consecutive elements, at least one of them has to be present, right? So what we are doing is we are bringing a recurrence here, right? We are solving it using recurrence. If n comma last, what does if n comma last means? Or let's say if n comma 0 comma 1, last is just 0 comma 1, right? So if n 0 or 1, so let's talk about if n 0 first, right? If n 0 comma 1, this is our DP state. What is if n 0? Maximum sum we can get, maximum sum we can get from first n elements, from first n elements, provided we have not taken the n plus 1th element. What is the maximum sum we can get from the first n elements, provided we have not taken the n plus 1th element, right? So this is a very common technique to solve a DP problem. Whenever you have to have a relation about whether you have taken the last item or not taken the last item, right, on the previous step. So you can just maintain an additional state 0/1. 0 means you have not taken the last item, that is n plus 1th element. 1 means you have taken the last n plus 1th element, right? So if you haven't taken the n plus 1th element, right, so you have a n, after that there is a n plus 1, and you haven't taken this, so you have to take the nth element. You have to take the nth element, because for any two consecutive elements, a n and n plus 1, one of them must be present. You have told that you have not taken n plus 1th element, so you have to take nth element. So if you are taking nth element, where do you go? What is the state that you go to? You are left with n minus 1 elements. What does 0 represent? Whether you have taken the next element, that is n plus 1th element. For n minus 1, n plus 1th element is the nth element. So whether you have taken nth element or not, yes, by n I mean the element at the ith index. N is the index here. Just assume the elements a1 to an. So we are talking about any arbitrary n here, nth element, right? So if n minus 1 is, what is the sum you can get from the first n minus 1 elements? So in a n minus 1 is here. First n minus 1 elements, what is the sum you can get? And what is the second state? It should be 1, because you are taking the nth element. You are taking the nth element. So it will be 1. And you have to add to this. What does this return? It will return the maximum sum. What is the f? What should f n0 return? It should return the maximum sum from the first n elements, and you have taken the nth element, so you should add the contribution of the nth element to it. So you are adding f n minus 1 plus a of n, right? So that is f n0. Is f n0 clear with everyone? Just let me know if f n0 is clear with everyone. What is f n0? The maximum sum we can get from the first n elements, provided we have not taken the n plus 1th element. So we have n elements like this, a1, a2, an, and we have an plus 1, right? So what is the maximum sum we can get from the first n elements, provided we have not taken the n plus 1th element? So in that case, we are forced to take the nth element. Otherwise, this consecutive element will not contain any of them. So we have to take this. Where do we go to? If we take the nth element, we go to n minus 1, first n minus 1 elements, and 1 it will be, because we have taken the nth element, and we have to add the contribution of nth element as well. And if n minus 1 returns the maximum sum from the first n minus 1 elements. So that is f n0. Similarly, what is f n1? What is f n1? Maximum sum we can get from the first n elements, provided we have taken the nth element, taken the n plus 1th element. So we have taken the n plus 1th element, that is we have n elements a1, an, and we have a n plus 1, right? So we are, what is the maximum sum we can get from the first n elements up to n, provided we have taken this n plus 1th element. So for nth element we have a choice if we want to take it or if we don't want to take it. We have a choice here. So if we take it, we will go to n minus 1 elements. We have taken the nth element and we will add the contribution of the nth element, right? If we don't take it, we'll go to n minus 1 elements and we haven't taken the nth element, and we will also not add its contribution, that is plus a of n, because we haven't taken it. So whichever is the maximum, we want that out. We want the maximum sum. So we want the maximum of these two values. So is it clear with everyone how is this coming, how we are coming with this recurrence? So that's exactly what I've written in code. dpi0 is dpi minus 1 1 plus a of I minus 1. That is, we have to take the ith element. And dpi1 is max of dpi minus 1 0 and dpi minus 1 1 plus a of I minus 1. Is it clear with everyone how we are coming with the recurrence? Okay. Okay, so if it is clear with everyone, so I think that should be it. Like these were the two questions, pretty simple ones, and I believe that you have understood how to solve them. So this is actually a trick. Like whenever you are given a condition, like whether you have taken the last element or you have to take from consecutive elements, you have to take one of them always or something like that. In those cases, or you cannot take from consecutive elements, you cannot take two consecutive elements or something like that. In those cases, you can maintain a state 0/1. 0 means you haven't taken the I plus 1th element. 1 means you have taken the I plus 1th element, right? So this is a pretty common technique that's used. So we have just leveraged it, right? So I believe that it's clear with everyone. So if it's clear, we can end the stream here. So thank you guys for joining and have a good night.